All right, so 6.1, graphs of functions. We're going to find the vertical asymptote, horizontal asymptote, slant asymptotes, any holes, x-intercepts, and y-intercepts. We're putting it all together right here, folks. So hopefully this video will help out. All right, here's our function. F of x equals x squared plus 1 over x minus 1. All right, first thing I like to do, I like to find my vertical asymptotes. Now to find the vertical asymptote, what do I need to do? Well, I need to make sure that my rational function is simplified, factored. If anything cancels, I need to cancel it out. Well, the numerator, x squared plus 1, we cannot factor this. Denominator, x minus 1, can't factor that either. So there's no factoring and canceling of terms here. So I know right off the bat we don't have any holes. So what I'm going to do to find the vertical asymptote, I'm going to set the denominator equal to 0, solve for x. X is equal to plus 1 to both sides. I get x equal to 1. That's my vertical asymptote. Cool. Now, horizontal asymptote. Horizontal asymptote. How do we do it? Botten eats DC. Okay, Botten eats DC. What do we have here? The numerator degree is degree 2. The denominator degree is degree, exponent 1, degree 1. So bigger on top, no horizontal asymptote. So I'm going to say none here. Okay, none. Now, slant asymptote. Do we have a slant? The only time you have a slant is when the degree of the numerator is 1 bigger than the denominator. Guess what? That is exactly what we have here. So we do have a slant asymptote. So good problem to see how to find a slant asymptote. We got to use long division. So x squared plus 1 divided by x minus 1. Okay, let me write this kind of like that. So I'm dividing by x minus 1. Now, to do this, I can use synthetic or I can use long. Either way, it doesn't matter. Some teachers only like to teach synthetic, so I'll just show you the synthetic way. I set this piece equal to 0, and I get what? X equals 1, right? Didn't we already solve that there? So I put 1 in the box, and then I look at this and I write out the coefficients. The first coefficient is a 1. Well, the next number I see is a 1, but guess what? Between the x squared and the 1 is an x term, but there's no x term there, so I put 0x. So I need to put a 0 there and then put my 1. So don't forget about it. If you're missing a term, don't just leave it off. Put a 0 there. Keep its place value. Drop the 1. 1 times 1 gets me 1. Put the 1 there. Add 0 and 1, I get 1 again. 1 times 1 is 1. Add it here, I get 2. Remember, this is the remainder. This is my number. That's my x. So I have x plus 1 plus 2 over, what did I divide by? X minus 1. So as x gets really big, okay, this remainder goes to 0. So this remainder goes away. So my slant asymptote is equal to y equals x plus 1. That's how I do it. Slant asymptote. Y equals x plus 1. All right. So let's start drawing this bad boy. See if we can't get it done. So let's do a little sticky note. Okay. I'm not going to promise this will be perfect, but, be good enough for government work. All right, guys. So what are we doing here? What are we doing? Well, we know we've got a vertical asymptote. Red means don't cross that stop sign, right? Don't speed through a red light. So we're never going to cross this vertical line at x equal 1. Okay, that's x equal 1. Slant asymptote. Slant asymptote. The line y equal x plus 1. This passes through the intercept at 1, and it has a slope of 1. So, looks something like this. Okay. Now, let's see how the curve actually bends. Okay, how does the curve bend? Well, one thing that might help us out here is if we do our intercepts. So, let's see here. X-intercept, what do? I set y equal to 0. So y here is f of x. So we'll have 0 equals x squared plus 1 over x minus 1. If I try to solve this, multiply by x minus 1 on both sides. What's 0 times something? It's just 0, right? So I get 0 equals x squared plus 1. Now, is there a number that I can square and add 1 to it and get 0? Not a real one. So there's no real solution here. And you see when you take the square root, negative number, no real solution. So what does that mean? That means that there's no x-intercepts. Okay? Now, y-intercept. Y-intercept. Set x equal to 0, right? So everywhere I see an x, I put a 0. So I get 0 squared plus 1 over 0 minus 1. Plug that in, I get 1 over negative 1, which is negative 1. So at 0x, I have a negative 1 value. So that's 0 and then negative 1. That point is right there. Okay. So what does this look like? This curve actually bends down this way, and then it gets close to my asymptote over here. Okay. Now, how would I get the other piece of it? Well, one thing I can do is I can just plug in a number. Anytime we're graphing something and we're not quite sure what it looks like, if you don't know anything else, you can at least plug in a number. Okay. Can I plug in x equal to 1? No, it's a vertical asymptote there, so it's undefined. So if I plug in 1 here, it's 1 divided, or we're dividing by 0, which is bad. So maybe try plugging in a 2. So I can get, so I know, like, does my curve do this? Does it do that? What does it do, right? So plug in 2. So f of 2 is going to be 2 squared plus 1 over 2 minus 1. So 2 squared plus 1, that's 5, over 2 minus 1, that's 1, that's 5. So my point is 2 comma 5. So my point is 2. I go over 2 and up. 1, 2, 3, 4, 5. Okay. And so my curve is going to follow the vertical asymptote here and the slant asymptote over there. And so that point there is 2 comma 5. Okay. All right. Hopefully that was helpful for you. If not, maybe this next one will be. Okay. Let's do this. X squared minus x over x minus 1. Okay, vertical asymptotes. To find vertical asymptotes, what do I got to do? First, I want to simplify. Can it simplify? Well, when I look at the denominator, it's just x minus 1. So that's good. But the numerator has an x in both terms, so I'm going to factor an x out and have x times x minus 1. Ooh, this looks good. Why does this look good for us? Because I see these two factors here cancel. How about that? That's pretty neat. Because now this reduces to x. So my whole function, So maybe I had some g of x here. The whole function becomes x as long as what's true. As long as this x minus 1 is not equal to 0. If it were equal to 0, I'd have like 0 over 0, which is bad. That's undefined, okay? So as long as x is not equal to 1, then this is true. So what's happening at 1? What's happening at 1? Well, this is what's known as a hole. Okay, so when I see factors cancel like this, then I'm going to end up having a hole there. Now, vertical asymptote. Is there a vertical asymptote for the equation y equal x or g of x equal to x for this one? Don't think so. I think it's just a line that's slope 1. Okay, so there is none. So you need to be careful. You might be tempted to set the denominator equal to 0 there, and you get x equals 1. But the problem is that's not a vertical asymptote. It's a hole. Okay, so there's a hole at x equal to 1. Okay, there's a hole there. Now, technically it's at a location 1 comma 1, but I'm going to be okay if you just put x equal to 1. All right, horizontal asymptote. With a horizontal asymptote, what do we have? We've got the numerator degree. Looks like it's larger than the denominator degree. So guess what? Bigger on top, no horizontal asymptote. Okay, no horizontal asymptote. Bow-Botten. Okay. So, slant asymptote. Do we have a slant? Slant, the degree of the numerator is 1 larger than the degree of the denominator. The degree here is 2. The degree here is 1. So, yeah, we do have a slant. So how does the slant work? Well, if you do the long division here, you end up getting x, and I'll just show you. Might as well, it's not going to take that long to do. We've already done the work. I mean, when we factored here and we got x, I'm just going to prove it to you, okay? X times x minus 1, that's x squared minus x if I distribute. So I put the x here, and I type in x squared minus x, draw a line, change the sign, add those up, I get 0 remainder. So my answer is just x. So y equals x is my slant asymptote. This is kind of weird, okay? Kind of weird that your slant asymptote is actually the same equation, but it is not the same equation, okay? The slant asymptote is the line y equal x. The equation is g of x, which equals x, except for x equal to 1, okay? There's a difference here. What is the difference? Here's the difference. When you graph this thing, this is what the line y equal x looks like, right? G of x looks like this. You graph it, but then what happens at 1? There's a hole in your graph. There's a hole in the graph, okay? This is g of x. Right? So be careful there. That's very different. So when you graph this on your test, you need to make sure to label those holes by putting a circle there. That's what I'm going to be looking for. You may not be able to tell in your calculator, and that's how I know, did the person know what was going on or did they just do their calculator, right? Okay. Let's do one more. And then we'll be finished for test material, or I guess, you know, chapter 6 material for this anyway. Okay. X squared plus 1 over x squared plus 2x minus 15. Okay, so maybe I've got some h of x equals this right here. First thing I want to do, vertical asymptotes, horizontal asymptotes, slant asymptotes, any holes, etc., etc. Okay. So, how do we do this? How do we do it? Well, first let's do the vertical asymptote. First thing I'm going to do is factor. The numerator cannot be factored. We've already run through that type of problem at the first of this video. So x squared plus 1 is not factorable, not with real coefficients. And so this is a trinomial, I think, t-chart. So I want something to multiply to negative 15 and add to 2. Well, 5 times 3... Okay, let's make this negative 3. And so that's 5 minus 3, that's 2. So, and that multiplies to negative 15, so we're good. So let's do AC method. So 5 and negative 3 are my numbers. So I have x squared plus 5x minus 3x minus 15. I group, so I group the first two, I group the second two, make sure a plus is in the middle. Pull an x out, I have x plus 5 times x, and then I want to make this second piece look the same as this one here. So what do I need to do? I need to pull a negative 3 out. If I pull a negative 3 out, I get x. If I pull a negative 3 out, I get positive 5. And so now I'm cooking with peanut oil. Okay? So I can factor an x plus 5 out of both of those, and what am I left with? X minus 3 here. Okay? Now you didn't have to use the AC method here. I just did to show you how to do it, just to make sure you know what's going on. The reason we didn't have to use it here is because there was a coefficient of 1 in front. So once you know these numbers here, 5 and negative 3, then you know it's x plus 5, x minus 3 when that coefficient is 1 there. So a little trick to help you shortcut. Okay. When I look at this, no factors cancel. So when I set the bottom equal to 0, the denominator, it gives me x equals negative 5, and then it gives me x equals to 3. Okay, how did I do that? I set each factor equal to 0 and solve for x. All right, so my vertical asymptotes are negative 5 and 3. I'm going to make that red just because, you know, our stop sign, our red light, we've never crossed the red. Okay. Horizontal asymptote. Do we have one? The numerator degree is what? The degree is 2. Let me exit down here. 1, 2. The degree of the denominator is also degree 2. So what does that tell me? Each DC, exponents are the same. Divide coefficients. What's the lead coefficient in the numerator? It's a 1. What's the lead coefficient in the denominator? It's a 1. So y equals 1 over 1. So horizontal asymptote, hey, right? H-A-Y. Y equals a number. Y equals 1. Okay, if there's a horizontal asymptote, then there's no slant asymptote. We're good to go. Because what do I know about slant? Slant has to be 1 greater in the numerator than the denominator, but they're the same. So guess what? It's no go. Holes. There were no holes because when we factored, nothing canceled. So no holes. X-intercepts. Do I have an x-intercept? I set y equal to 0, so 0 equals x squared plus 1 over x squared plus 2x minus 15. Okay, the only way a fraction is 0 is when the numerator is 0. Can this thing ever equal 0? We talked about that at the first of the video. It can't be 0, not unless it's imaginary. So there's none here. Y-intercept. Set x equal to 0. So if h of 0 equals 0 squared plus 1 over 0 squared plus 2 times 0 minus 15. So this is 1 over negative 15. Okay, not a big number. It's actually pretty close to 0. So my y-intercept is 0 comma 1 over 15, and it's negative, so it's right below. So let's see if we can't graph this. Okay, see if we can't graph it. Intercept about right there. Okay, vertical asymptotes I'll put in red, -5 and 3. X equals -5. X equals 3. Okay, horizontal asymptote. Horizontal asymptote, y equal 1. So maybe something like this. Y equal 1. So what's going on here with our graph? We can get an idea if we actually throw it in our calculator. Okay, calculator. So with the calculator, I'm going to do parentheses. I'm going to put in x squared plus 1, close parentheses, divide, open parentheses, x squared plus 2x minus 15, close parentheses, enter. And so I'm going to hit the graph button, and I get an idea of what the shape is going to look like. Okay? So that kind of gives you a good idea of what your shape is going to look like. Looks like we're hugging that line, that horizontal line on the top side. On the bottom side, it looks like it doesn't pass the x-axis, which is good because we found that there was no x-intercept, right? So we wouldn't expect it to cross this. So it looks like we're going to get like really close to it, but then it comes right back down, okay? And then over here, it looks something like this, and same thing over here looks something like that. Now, we could find another point if you were asked to find another point on the graph, okay? Don't pick x equal -5 or 3. Why? Because those are where the vertical asymptotes are. That would be bad to plug in to our function. So maybe we can plug in like a 4 or something, x equal to 4. See where that outputs up here. Okay, so 4 comma what, right? That's what we're looking for. So if I plug a 4 into h, what do I get? Get 4 squared plus 1 over 4 squared plus 2 times 4 minus 15. So 4 squared, that's 16. So that's 17 over, okay, 16 and 8. That's 24. Take away 15. That's 9, right? Did I do that right? Yeah. Okay. So that's basically 2. So 17 over 9. That's just shy of 2. So that would be how you would find a second, another point. If you were asked to find another point on the graph. Okay, you just take a number, plug it in. Heck, even easier than that is if you got your calculator, you can go to second graph, which is the table, and then you can look and you can see table values here. Okay, so you just pick a value, that makes you feel good, whatever, I don't care. Okay, so 8 comma 1, that seems like a good value to pick, right? That's easy to write. 5 comma 1.3, that's an easy one to write. Things like that, just use your head, all right? Don't get too complicated. You want something that what the fraction version of it would be. Okay. I hope that this was enlightening for you, and let me know if you have any questions.